Hello students, I just wanted to record AM modulators, AM demodulators so that I can save some of my class timings. We will see about AM demodulators. See, what is AM demodulators? We are just getting back our original signal. Uh, the circuit which you see is a rectifier detector method of demodulating your AM wave. Now, what is done first? You have here an AM signal. You know AM signal is nothing but A plus M of t into cos omega t, Ct. The one you see is the AM signal and it is passed through a diode, single diode. And you all know that diode behaves as a rectifier, right? It will pass only positive half cycle, but it will suppress all negative half cycle, which you can see from this figure. Now what we got after the diode is only positive half cycle of the AM wave, amplitude modulated wave, right? Now what is required in this is nothing but the peaks. The peaks are required because those peaks represents the demodulated wave, right? Now see, we are passing this through a low pass filter. Why we are passing this through a low pass filter? Because we are supposed to extract only the baseband signal. We are supposed to extract only baseband signal. Baseband signal means your m of t out of the equation, right? But we don't want to have that cos omega ct, right? So that's why we will remove the carrier frequency by using a low pass filter, right? Now you can see here, that A plus M of t cos omega ct into Wt. You know, Wt is actually uh, the diode switching action. Diode is going to generate a square wave, right? Now see here, cos omega Wt is actually a Fourier series representation of the pulse string. That is half plus 2 by pi cos omega ct minus 1 by 3, right? So now you just have to simplify this equation. You get A plus M of t, okay, into cos omega ct plus half, multiply entire equation, right? So you will have, when you multiply this, you will have a term, right? 1 by pi A plus M of t plus other higher frequencies. Now that M of t is a baseband frequency. That means M of t, which is your message signal, is a baseband signal, that is low frequency signal. So now you have to design your low pass filter in such a way that it will pass only the low frequency signal, that is your message signal. All other frequency will be blocked, which you can see here, right? And after that, it has a DC term, right? It is actually giving you DC term. You can see the waveform 1 by pi A plus M of t, right? So that has to be, that DC term has to be removed. So that is that is passed by using a capacitor. So that capacitor blocks the DC term and it will pass only the AC term. So what you're going to get output is 1 by pi into M of t. So definitely you have demodulated M of t by using this. This is one method of rectifying demodulating your AM wave. Another method of demodulating AM wave is using analog detector. What is an analog detector? Analog detector nothing but it detects the peak of the AM wave. Once again, given an AM signal like this, right? it is passed through the diode. That means it is going to remove all the negative half cycles, and then it is passed through a capacitor, right? The value is should not be too small and too large with an intermediate value. See what happens here? During positive half cycle, you can see that it is charging, right? During positive half cycle, it is charging, right? And then when it goes negative half cycle, it retains the charge. And see, you can see the charge is retained here. And then it continues like this. You can see the waveforms which you can see here. Okay. Now you can see if the RC is too large, right? Then it won't catch those peaks, right? So for that you have a formula which is RC should be much greater than 1 by omega C with the carrier frequency, and much less than 1 by 2 pi into B, where B is the bandwidth of the signal. Right? Okay. So this is what the envelope detector is. Okay. So in this way we can demodulate our amplitude modulated